So this is part 3 of our video series with developing measurement concepts. So we've looked at kindergarten standards, we looked at first grade standards, we're going to look at second grade standards today so you can get a good idea of this progression of how things are building. So now students are working with the centimeter ruler and the inches as well. So we've got the metric part, we've got the English standard ruler. So we're going to do a lot of estimating. We're going to do approximates, and because some of the details of this we're not to that point yet. So when we want kids to start using a ruler so they can start seeing measuring those whole amounts and approximately. So when we're saying use a centimeter ruler to measure the length of the object below, I want you to look at that in centimeters and in inches. So I would suggest that if you don't have a centimeter ruler, that you go ahead and purchase one. And so they're extremely cheap, but that you have one that you can work on with your homework, or if you need to print out a paper copy one and cut that out so you can use that as a measurement tool for the homework. So here, when we're looking at the top section on our ruler here, the top section will be in centimeters and the bottom section will be in inches. So when we're calculating this, I'm just going to slide this over. Notice that we definitely want to line up our pieces for 0. So we want 0 to be right there at that line so we can measure from one side of the animal track to the other side. So we look at this top section being centimeters, and so we've got 1 centimeter, 2 centimeters, about 3 centimeters long. And then when we're thinking in inches, we've got 1 inch, and so here would be our 2 inches, and this would be halfway. So what we're seeing is it's closer to 1 inch. It's we could say it's a little bit more than an inch, or we could say it's about 1 inch, a little bit larger. So we can use that estimation lingo when we're dealing with when we're talking with the kids. The next one, when we look at the picture of the turtle. So we want to go ahead and line that up. We'll look at the top section, and we're at 0. So we've got 1, 2, 3, 4, 5, 6, and then there's 7. So we're just right there around 6.5. So we can use that language of 6.5, or we could say between 6 and 6.5 centimeters. Definitely closer to 6 centimeters than it is 7. And then we're thinking about inches. So we've got 1 inch there, we've got 2 inches here, we've got 3 inches. So we could say about 2.5 inches long. And so it's a good benchmark of that 1/2 marker. We've talked in fraction form about what is a half and what is a fourth, and with our first grade, and we're going to look at that. We're going to continue that on in this video when we're dealing with the second grade standard. So it's a good language to already begin is talking about benchmarks. Here's a whole inch. Halfway, well, this would be 1/2 of an inch. So we can look at, we've got 1, 2 full inches, and then not quite 3. So we're about that 2.5 mark. Next, we'll look at the sandwich. And so with that, let's slide our ruler over. And then we're starting at 0, so we're looking at centimeters. So we've got 1, 2, 3, 4, 5, 6, 7, 8. There's 9. A little close to 8.5. So we would say about 8 centimeters long. And then we think about our inches. So there's There's 1 inch here. Remember our 0. So there's 1 inch, there's 2 inches, there's 3 inches, there's 4 inches. So it's definitely closer, as we see about it right in there. So it's definitely closer to about 3 inches long. And notice that the wording wants about, it wants estimates. A really, jumping to the bottom here, a really good website that I would encourage you all to explore. And you do have an assignment that deals with websites and apps that you can look at later, but definitely want you to bookmark Estimation 180, because it Andrew Stadel really gives you, all teachers, some really good resources that help the students think about estimation and how you can pick out things in pictures and whatnot to make a good estimate. And the strategies that come out in the discussions are really powerful, because I've used this in class before with students, and you really get a good perspective of how certain students are thinking through problem simulations that are asking for estimates. So with our second grade measurement and data, standard 3, the height of a door is about 2 centimeters or 2 meters tall. So this is something really good that you can have in class, kids experience. Most students making a bad choice aren't comfortable or quite understand the difference in the measurement units. So when we're dealing with centimeters or meters, well, they need to hold a meter stick, and they need to see, well, this is a meter stick, and this is how many centimeters are equivalent to this. So when they're having to make a decision, is the height of the door 2 centimeters, or would it be 2 meters tall? And we would say, well, that would be meters. And the benchmark that they're thinking of to make that estimate is, well, maybe the meter stick comes up to me, this comes up, on my height to here, so I know that 2 of those would be equivalent to a door. Maybe that's what a student's thinking, or that's how that they would express their thought. The length of a pen, is that length of a pen going to be 10 centimeters or 10 meters? And that's going to be your centimeters. Benchmark that they could use is they are starting to think about something that they know is a certain amount, and maybe they're thinking, well, I know a pen is approximately half of a ruler, which contains 30 centimeters approximately. So I know the half of that is about the equivalent length of a pen. That's just me throwing out an idea. What you want is you want the kids to be able to justify that. Now, that can be through writing, that can be through an oral description, a discussion in class. Small groups share out into the big group of reasons why they chose what they chose. The length of a car, 4 centimeters or 4 meters. So we're dealing with meters. Again, might reference something like, well, I know the door is about 2 meters. So if I set that next to each other, that would be about 4 meters, which would be equivalent to approximate the length of a certain car. The length of a bed is about 2 centimeters or 2 meters. Well, we would say about 2 meters, and then you're just asking them to justify. Dinner plate, 20 centimeters or 20 meters. We would know that that would be about 20 centimeters. So really want to encourage you to look at that website. It's interesting, challenging, and Andrew Stadel did a wonderful job with that. So I would definitely put that as a bookmark and use that in the future. Another type of question that you can give the students is other things that maybe they've experienced with, that they might see in their classroom. whiteboards. Okay, so the whiteboard that's hanging from the wall in a classroom, what would you approximate that? 3 meters or 45 centimeters? Well, they would, thinking about it, we'd want to go with the 3 meters. A banana, about 18 centimeters. A DVD disc, so it would be a little bit smaller. And what we're talking about is that diameter, that length across that circular. So we're talking about that DVD player, and we're thinking about that distance, that diameter distance across. A pen, 16 centimeters, and a swimming pool, much closer to the 50 meters. And different pools, of course, have different lengths. So we might be thinking about a neighborhood pool or an aquatic park, some sort that would be much longer. So that 50 meters would be much, much bigger there. Here you've got some examples that in your notes or on homework, you would want to measure the length of the lines that are given. And so you would take your measurement tool, and I'm just saying this to reiterate it because you want to reiterate that with your students, is just make sure that you certainly can measure at a different location other than 0. You just have to understand how you're going to adjust your numbers. So if it was a broken ruler or a broken centimeter ruler, you could measure with we can move the ruler here. We just have to know that I've just created a new 0. And so if it was 2 centimeters on the ruler there, that I need to understand that that's 0, and that 3 centimeters would be my new 1 and not 3. So using the ruler, I would encourage them to go ahead and line that up. And so we should see about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, about 12 centimeters. And then line B, we would line that up. We'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. So about 9 centimeters for line B. So line A is about how many centimeters longer, so they are familiar with the longer and the shorter. And so that would be just a subtraction of that. And line B, line A and B are about how many centimeters combined. So a good benchmark, 12 and 10, so it's about 22. That's just the easy, quick adding with tens. Not that speed is a must, but it just allows them to get to an answer a little faster if they mentally. So if they're working with groups of 10, one of the standards in their grade level is to be able to add 10 and subtract 10 fluently given any number. So given 12 plus 10 is about 22. Now they can certainly go ahead and add that up and get 21, that's fine. But again, you're talking about. So 21 is not a wrong answer. 22 is not a wrong answer. It's just, you're just trying to get that approximation. So here we've got line X, line Y, line Z. And so we're going to look at these comparisons. So I want in centimeters. So we're looking at 1, 2, 3, 4, 5, 6, 7, about 8 centimeters. Line X is about 8 centimeters. And then line Y would be 1, 2, 3, 4, 5, 6, 7, 8, about 9 centimeters. And then line Z is about 5. So knowing that, now we can answer some questions. X, Y, and Z are about how many combined. So we could say about 20. We could add these and say 8, 9, and 5. Okay. We could say 10, 10, and 5. If you're looking at estimation, we could round the 8 and the 9 up. If we're just having them do an estimate, so about 25. Well, we know we rounded up on 2 of them. So thinking about that estimation, so we know it's going to be less than 25. Line Z is about how many shorter than line X. So, we could just go with we know 8 and 5, so it's 3. Line X is about how many centimeters shorter than line Y, and it's about 1. Line Y is about how many centimeters longer than Z, it's about 4. Line X doubled. Line X doubled is about, well, we have to double, so that's 16. How much more is it than 9? Well, we could say about 6. We could do 16 and 10 and think that that's about 6. Or we could use 7 if they want to do the subtraction there. That's fine. But remember, this is all about approximating and not getting the measurement exactly right when you're using the ruler, because we're just still second grade standards. We're still just approximating. Here's an example where you're looking at the broken ruler. And so we're looking at that idea where it doesn't have to start at 0. Any student could pick a different number here. We just want to work within the numbers that we have. So let's say that a student started here as their 0. Well, a cricket jumped 5 centimeters forward. So 1, 2, 3, 4, 5. And so now they're at 24, and then it stopped. Okay, sorry, I didn't start at 23. So we're starting at 23 on the ruler. And the cricket jumped 5 centimeters forward. So 1, 2, 3, 4, 5. So now it's at 28, and then it jumped back 9. So there's lots of ways of thinking about, how would you jump back? You could jump back 10, and that would put you at 18, but 10 was too much. We needed to come back 1, so they would end up at 19. Or they could just count, they already went forward 5, so we know that's backward 5, 6, 7, 8, 9. So they're going to end up at 19. So using different strategies to move forward and backward is good to allow the students to discuss that. Now, it did say start at 23 on the ruler. You could have started anywhere you wanted to, but you wanted to make sure that backing up 9, that you're still within the ruler. Looking at the next one, so each part of the path below is 4 length units. So we don't know what this exactly measures, but we're saying that each one is 4. So students could label that if they'd like. And then we see how many groups of 4. We see we've got 8 groups of 4. And so that would be 32, or a student might have to, maybe they're working fluently and they know 8 times 5 is 40, and we just back up a group of 8, and so we're at 32. Here we've got, so Mara's ribbon is 26 centimeters long, and Colleen's ribbon is 14 centimeters shorter, so 26. We know that it's 14 shorter than that, so they can do a subtraction to figure out what that length is. And then if we know this is 14, and so we know this is 12, so 12 plus 14 should give us the length of Marin's ribbon. Next, working with money is something that is just not emphasized enough. And it's a great counting skill and understanding the counting up, starting with the larger number of 5 cents and then counting the 3 pennies and getting using the symbol of 8 cents. You can, of course, make the extension if you need to or would like to for certain students, understanding that that is 8 out of 100. But you are really kind of stretching that idea. 8 out of 100 pennies. Now that could be an extension if you would like to go there, but 8 cents, this way of writing that would be fine. So you know you got 10 and 4, so 14 cents. So it's really looking at, well, let's recognize that larger amount and recognizing it, and then here you have a 10, but recognizing that the nickels are both 5, so there's another 10 and 5, so now we've got 25 cents. Or you could look at that as 10 plus 15 and still get 25. So really working with adding mentally using the money to represent that. Here we've got 10 and we've got 5 and we've got 4. So that would be 19 cents. This is one where you recognize the value of each of the coins and then just a continuation of that. And so here I've got 20 and 5 and 1. So we'd have 26 cents. Trying to combine as much as you can is great. This is 25, and then this is 10, and this is 1. So now you're thinking 25 and 10, and this is a big key to having students just being fluent with 10 more, 10 less. And so 25 plus 10 would be 35 plus 1, so we're at 36 cents. And then here you've got 25, and then this is 10 and 10, so that's 20, 5 and 2. So knowing that this is 45 and 5, and so I wouldn't encourage the students to make that 7. I would just continue to go with, so 45 and 5 is 50, and now we've got 52 cents. This is an activity that I used with all of my own children, and that is figuring out ways to make a certain amount of change and using the least amount of coins as possible. Now, there's nothing wrong with the different methods and the different breakdowns, but as we all know, when we're working with money, we want to give back the minimal amount of coins possible. So that's something that we want to encourage the kids, celebrate their answers, but then understand, is there a more efficient way to get there? And then have them think about, let's try to use the least amount of coins possible. So here we're looking at 20 and 5 and 1. So we are looking at 26 cents, but is there a way that we can combine some things? So now you start to bring in equivalents with the coins. So we see that this is 25. Well, what do we know that's 25? Well, we could use a quarter and a penny to get the 20. So now we're only using 2 coins. With the 35 cents, is there a way? Well, we see here, this is equivalent to a quarter and a dime. So now we're only using 2 coins to get there. Now, if a student wants to bring in pennies and additional pennies or additional nickels, and that's what makes sense to them, great. Celebrate that answer. Just continue to encourage them in that, just a work in progress of how we can combine and get down to the most efficient. Well, it might be that they need to play with the money. They need to manipulate the money. They need to see that, okay, well, a quarter is equal to this, and they need to move it. They need to manipulate it. They need to help create a chart, and they can work in groups or individually to see patterns and how number strings are equal. 25. Well, that's equal to 2 dimes and a nickel. Or, they can break down to how many nickels and then how many pennies. And then they can see, well, what's the most efficient way to get to this number? Same thing here. I'm trying to get to 55 cents. And 2 quarters and a nickel make 55 cents. But is there another way to get to 55? Yeah, we could break down the quarters. But what happens is you start to create more coins. And now we think about, well, to get to 55, what's the most efficient way to get there? And this would be your most efficient. 75 cents. Is there another way to get to those 3 quarters? Yes, but what are you creating? You're creating more coins. Nothing wrong with the answer. You want to see another way to get to 75. You want them to show you a different way to get there. But then once that's finished, it's like, well, what's the most efficient way? Well, 75 cents is really to just keep it at the 3 quarters. I put this down here, practicing counting back change. And I have mentioned this in different classes, and I also want to mention it again. It's a great station activity in your classroom for you to be someone that challenges them. Hey, I'm paying with, it's 84 cents and I'm paying with $1. How much change am I going to get back? So you force them to become the cashier. You force them to become the banker in the game of Monopoly. You are forcing them to count back the change correctly. It's a great skill. They need to know how to do that, and not be so reliant on a calculator or that subtraction model. This is actually counting up. So it's just another alternative to subtraction. But it's a great thing to have in your class. And you can be a rotation. When you're thinking about stations in your classroom and having the kids rotate during different stations, you could be one of those where they have to stop and you say, hey, I'm ordering this. It was $1.45 and I'm paying with $2. How much change do I get back? So having them learn that idea of counting up, starting within that $1 and then moving up based on where the kids are in their learning. And what I mean by that is, could be that it's $4.20 and I'm paying with a 5. What's my change back? Or it's $1.35 and I'm paying with a 5. What's my change? And so you're having dollar bills there so they can count back the change first and then adding up to the nearest dollar and then counting their dollar bills back. And I would assume that I can only assume that we've all played the game Monopoly, and this is a game where, as the banker, you can certainly use the strategies of counting up in order to give back the change when you're playing the game. Next, let's look at second grade geometry topics. And so these are more understanding the number of sides and the number of angles. So we're looking at attributes, characteristics. And then the polygon is in the word bank. And so it's just having the students write those words to represent. Well, a hexagon, so those are things that they have discussed in the past, looking at pattern blocks and whatnot. A hexagon is going to be 6 sides. Quadrilateral is going to be 4 sides. The triangle, 3, and the pentagon is 5. So we're looking at A, we see there's 4 sides, so this would be a quadrilateral. B, we recognize the 3 sides, so that would be a triangle. C is, we've got the 1, 2, 3, 4, 5 sides, so this is going to be your pentagon. D is that hexagon pattern block look, so this would be your hexagon. E is another shape of or another position of a triangle. And then here, F is a quadrilateral and a future term called a trapezoid, which they'll learn in the future. And there's nothing wrong with discussing what that is, but it does have 4 sides, so it's in the quadrilateral family. Again, just more practice with this. We see there's 4 sides, so we know we've got a quadrilateral. Here we've got 1, 2, 3, 4, 5. We got 6 sides, so this is an odd shaped hexagon, not like the pattern block that students are working with, but still has the 6 sides. And then here we've got 1, 2, 3, 4. We've got 5 sides there, so it is in the family of the pentagon. And then here we've got 4 sides, so we've got another quadrilateral. And another quadrilateral. Also, this is another version of a trapezoid. And if any student ever asks, well, how do you know it's a trapezoid? Well, you can talk about the parallel lines, that it has at least one, or a quadrilateral needs a pair of one pair of parallel lines. And then this next one is just another version of the triangle. Now, this is where you would want the students to use square tiles, or they can draw this out as well. But you're wanting them to construct a rectangle with 2 rows and 3 tiles with no overlaps. So this is also kind of beginning this idea of arrays with multiplication. So they want 2 rows with 3 tiles. So you would build that. So they have built a 2 by 3. So they have built a 2 by 3 rectangle. Or we can flip it and we could say we want 2 columns with 3 tiles. So this kind of goes back to that fluency idea of understanding that, well, it kind of goes back to where we all were kind of learning our multiplication facts. It's hard to say that, well, I know my 2's, but I don't know my 3's. Well, 2 times 3 is 6. So you certainly know 3 times 2 is 6. The problem that we had, I know that I had growing up, is that I was never encouraged to think about the commutative property on that. 2 times 3 is the same as 3 times 2. I was never encouraged to look at that in a geometric standpoint with area or pattern blocks or building geometric shapes. Students need to build, when they're learning this, they need to build a 2 by 3. They need to build a 3 by 2. They can use graph paper to do that. You can use pattern blocks to do that. If I want 5 rows, so I want 5 columns with, or 5 rows with 2 columns, so I'm basically building a 5 by 2. So here's my 2, here's my 5. You have created a rectangle. That's a 2 by 5. And then if you keep going, you can construct a rectangle that has 5 columns and 2 tiles. So now they see that they built a 2 by 5, and that rectangle looks like this. And then construct with 9 tiles, 9 tiles that equal. So what you want is, this is now E and F are kind of changing the game on them a little bit. Now they need to build, they need 9 tiles total. That has an equal number of rows and columns. So with that, they're actually creating a perfect square. It's got to have 9 total, and it does. And they see that this length is 3 and this length is 3. So if they have the same length and the same width, then they're dealing with a quadrilateral, a rectangle, but is specifically a square. Also could be called a rhombus. Construct a rectangle of 16 tiles that has equal number of rows and columns. So now they gather their 16 tiles. You're not telling them at all how they need to construct it. You're just giving them the total amount. And as they're building this, they come to the idea that this is going to be a 4 by 4, and that would be another square, another rectangle, a quadrilateral, a rhombus. Pattern blocks. When we're using pattern blocks and we've got a rhombus here, then you think about the pattern blocks that you have. You're going to have triangles, you're going to have the rhombus, you're going to have the trapezoids, you're going to have a square, and you're going to have the hexagon. So those are your pattern blocks that will come. You can Google those and look at those. Typically come in little baggies, and those are items and manipulatives that the students can use. So, and if you don't have those are easily printable, and you can cut those out and put those in baggies for students so that they can have, so they can start to determine equivalence with shapes. So identify the pattern blocks that's used to cover half of the rhombus. Well, if you think about half of that rhombus, if I use this line here to represent that, well, half of that rhombus would be a triangle. So the pattern block that used to cover half of that would be your triangle. And so here's what this picture here is, just what you would have, what the rhombus would look like after it has the 2 halves. Here we've got use 1 pattern block to cover half the hexagon. So when they have the hexagon here, they're thinking about, well, what pattern block to cover half of it? And the pattern block of the trapezoid would be used to cover half of that, because we can see that if I bring in the other half, it creates that hexagon. And so we'll draw a picture of the hexagon formed by 2 halves. Well, there's the other half, and there's my new picture. So both of these would represent that equivalence. Use a pattern block to cover 1/3 of the hexagon. So when we think about that, so now we want to think about that 1/3 of the hexagon is also going to be a rhombus. So how is that going to look? Well, a rhombus would look something like this when you input those. So you would see there's 1 rhomb. So you got 3 rhombi that would represent that. Next question is using a pattern block to cover a third of the trapezoid. So here we've got our trapezoid, and then they're going to be a little bit off with the size, but we can, when we put in 3 triangles, we'll just rotate our triangle so that we can fit that in there. So we would see that. Identify the pattern block used to cover a third of a trapezoid. Well, that's the whole. So a third of it we would see is the triangle. And then we've got a picture drawn of the trapezoid formed by the 3/3. All right, jumping into the next topic, we're looking at partitioning different shapes into halves, thirds, and fourths. So now we're bringing in the fraction halves, thirds, and fourths. So now we're really stressing, what's that denominator? What's that number in the denominator really mean when we're talking about the shape? Well, remember that represents how many pieces that we're dividing the whole. So do the shapes below show halves or thirds? And so now the question is about, okay, well, all of this one I'm seeing 2 parts, 2 parts, 2 parts, 2 parts. So this would represent halves. So if I erase those, and then if I want to draw one more line to partition each into fourths, so I want to create fourths. So what I already have there, I'm just going to go draw that line horizontally to create the 4 parts here, to create the 4 parts. And then I'm just going to go to another diagonal, and then I'm drawing another diameter. Part C says partition each rectangle into thirds and then shade the shapes. So I would just encourage you to go vertically or horizontally to do that. And so I want to create thirds. And then I want to show, I'm just going to show the shading of this because each one of those represents a third. So 3/3 is the same as 1 whole rectangle. Here I want to continue with 2/3. 2/3 would be 2 of these. And I know that's not exactly, I need to kind of move that a little bit. And then 1/3. So that would represent my 1/3. So you're just subdividing the rectangle into the parts, and then you're shading accordingly. So now we're thinking, let's partition this into fourths. So with the circle, everything's going to be fourths. So I'm just going to go ahead and draw those in. I know that, speaking from experience growing up dealing with fractions, I use circles. I remember seeing circles quite a bit. And there's nothing wrong with representing halves and fourths, and probably even thirds. What happens with circles is when you're looking at fifths or sixths or eighths, it gets really difficult to draw that. So I would move away from the circle and I would think about a rectangle. It's easier to draw those vertical or horizontal lines, and it gives students start to think about arrays in regard to area. So partition into fourths. Well, I want 4/4. Well, there's 1, 2, 3. There's 4/4. Here's my 3/4. Here's my 2/4, or half of that, and then here would be my 1/4. And so moving into that, we can look at the circular picture and think about clocks, minute hand, which the first grade standards, when everything was to the nearest half hour or full hour. Now we're starting to look at different times, like nearest 5 minutes. So if I want to draw 3:05, then I would need my hour hand, which would be smaller. And then the 5 minutes. The longer hand representing the minutes. 3:35. 4:10. So representing, the students understanding that that's 2 groups of 5 right here. This is 2 groups of 5 minutes, which is 10 minutes. So each of these partition into 5 minutes. And so that they, there's a lot of assumptions that we make with understanding a clock and the fractional idea of this. So kind of have to understand students are going to still struggle with the repetition of adding. They're starting to understand a little bit of what multiplication means, and then taking a clock and dissecting it into certain parts. You got to understand that you're looking at groups of 5 minutes all the way around, and 12 groups of 5 is going to give you 60 minutes or that whole hour. So when you're thinking about that second piece here, that 10 minutes, well, where does the 10 minutes fall? Well, that's 2 groups of 5. And so the more that they work with manipulating a clock and understanding where the minute hand goes, the hour hand, and creating that. So 6:25, so we would like to see a short hour hand here, and 6:25 to represent 25 minutes. 4:40, so we're looking at 4:40. And they actually make manipulative clocks where the students can hold them and move the hour hand and the minute hand. It's a great formative assessment piece. Of course, you can make your own if you needed to. If you're at a school district that couldn't provide that for you, you can make those out of paper and laminate those and use brads to kind of stick through the middle with the minute hand, hour hand, and be able to create your own clocks. 6:55, here's 6:55. Might even want to have them understand, well, at 6:55, we're almost at 7, so that is almost to 7. So at 5 minutes away, that hand's going to move. The hour hand will move closer to 7, and in 5 minutes, that minute hand will be vertically at the 12-hour mark. Here you're asking the students to go ahead and complete the missing 5 minutes. So this would be every 5 minutes. So there's 10 minutes, there's 15 minutes, there's 20 minutes, 25 minutes, and then we get to the 30 minutes, working our way this way. And then so we're just kind of skip counting by 5 minutes. And then we see that when we finally make our entire circle, we have gone 60 minutes. And then we've got elapsed time problems. So you can think about the number line with this. If Tracy arrives at school at 7:30 and she leaves school at 3:30, how long is Tracy at school? So it might be that students use the number line approach and think, well, 7:30 to 12:30 is 5 hours. And then how far to get to 3:30? Okay, so that would be 3 more hours. So then you could, see a total of 8 hours there. They could use a number line and go from 7:30 and just continue to make those jumps until they get to 3:30. And so again, Anna spent 3 hours at a dance party. She's finished at 6:15. So you can think maybe backing up 3 hours to be at 3:15. Andy finished Andy finished baseball practice at 4:30. His practice was 2 hours long. When did he start? So backing that up 2 hours to 2:30. So you are utilizing the number line. They could use the manipulative clocks to back up certain hour hands if they need to see that. And so here he took a road trip. He left Monday at 7 a.m., drove until 4. And then on Tuesday, he drove from 6 a.m. to 3 p.m. How long did he drive on Monday and Tuesday? So you can create those number line jumps. You know, you could say 7 o'clock to 12 o'clock. Well, that's 5 hours. And then 12 to 4. All right, so there's 4 hours. So nonstop, there's 9 hours. And then you're looking at the next day. You're looking at going from 6 o'clock to 12. And then maybe look at 12 to 3:30. And so you're just adding up your total hours. So this would be 3 hours and 30 minutes. So now you've got 9 hours and 30 minutes. So total, you would have 18 hours and 30 minutes. So those are good elapsed time problems that you can discuss with the kids. So again, reflection time. This is a time for you to, as you're taking notes on this and you're looking at your standards and you start to think, well, what did you learn from the second grade standards in the realm of measurement? So you're reflecting on that and you start to back it up. You can start to see that progression on question 4. Now look at that kindergarten to first grade to second grade progression. If you're a first grade, you end up being in a first grade classroom and you're thinking about measurement and data. Well, you know what they're learning in kinder and you know where they're going in second. Allows you to really kind of be flexible with where you need to make remediations, how you want to respond to that intervention, or how you can accelerate if needed. Start to think about what concerns you have with certain measurements. How would I teach this? What's this going to look like? What manipulatives do I need? What visuals do I need to help the students be successful with this? Do you see students struggling in this measurement? What could you do to help meet their needs? So all good things that you want to think about when you're reflecting. So this is ends the week 1 video on developing measurement concepts, and this is the 3rd video that dealt with second grade.